Norman, we're stood in front of an ECM machine built by yourselves at Anotronic. For the viewers at home, can you tell them a bit more?
Yes, this is a twin 2000 amp electrochemical machine. It's used specifically usually for production applications, and it will machine shallow recesses. It will deburr parts where you've got burrs need to be taken off. It will also improve the surface finish on parts which have been EDM'd or drilled or milled, where you've got machining lines that need to come off. And it's a very fast process.
So can you give me a few industry examples?
Yes, well, we saw one example earlier today, of course, when we talked upstairs, and that was recesses put into a sheep shearing comb for Australia. And the whole idea of that is to reduce the surface area so the two plates will slide across each other very easily. Now, if you come to grind that surface, the timescale was very long, about 10 minutes. We produced it in 32 seconds. So it's a very fast process. Another process is to put recesses in areas where you can't actually access very easily and you can't machine easily. So down tubes where you might have a spiral, which is a helix to carry oil, for instance, from a bearing to another one.
So what's the science behind it? How does it actually work?
Well, the science is really more or less reverse plating. So what you've got is a direct current circuit. The component itself carries a positive charge. The tool, which is called the electrode, carries a negative charge. And we flow a conductive fluid between the two, which we call an electrolyte, which is sodium nitrate in water. It's a salt, a neutral salt. And when current is applied, material comes off the workpiece as a metal hydroxide, which can be filtered by a filter press or a centrifuge or just static settling, and then it's reused in the process. So it's a very user-friendly process where the tool doesn't wear out. The electrolyte can be reused. The only high cost is the power. You use quite a high power.
And I know this is a vast machine, it's huge, but you do smaller machines, don't you?
We do machines down to about half the size of one half of this, which is about, we'll go through a standard doorway, and we'll use a single phase power supply, and we'll deliver 0 to 15 volts at 100 amps.
I guess that's great for somebody maybe doing turn parts, or maybe even milled parts that need improved surface finish or non-contact deburring.
That's right. Usually the problem with turn parts is that if there's cross holes put into it, the burrs on the inside are very difficult to remove. If you try and put something up the inside, maybe another drill, it just pushes the burr back into the cross holes that you put in. By using our process, you take the whole burr away, radius gently the corners, so any fluid that's got to go from the inside and pass through the holes themselves goes around the radiuses, and it's very easily taken through. So it's the perfect process.
And I know this machine's going to a university overseas, but in the UK, who's buying these? Is it universities? Is it turn part manufacturers?
No, mostly production people. It's people that are making things like valve bodies, any turned item, any milled item where you've got recesses in the inside that need to be cut. Aerospace, particularly car industries. A good example is some years ago we supplied a machine into TRW at Pontypool, and that was for doing brake cylinders. And if you look inside a brake cylinder, there's two holes that break out onto the inside, 3mm holes at an angle, and the burr that's left in there is pushed back into the hole because it's been honed afterwards, and we deburr those 500 an hour on a CNC machine with robot feeding. So it's an excellent process for production.
You're clever people here at Anotronic, aren't you?
Well, most of those are. I just direct them.
And how about the control? Is this easy to set?
Very easy, yes. What we do is to set things like the amperage the voltage that's required, the time that's required, and maintain the temperature of the electrolyte at the same rate. And as long as we keep those the same, then the product will deburr exactly the same each time.
And how do we know what those settings should be? Do they phone Anotronic, or is it easy to work out?
Well, it's fairly easy to work out. What you can do to start with is when you try and deburr something, you start off on a fairly low time basis, look at what you've produced, put it back in again, run it again for another few seconds, and keep doing that until you get the desired result. Add all your times together from what you've tried, run the next one at the total time, and that's your setting. It's as easy as that.